All right, the length of a vector, u1, u2, let's start in R2. So I've got a two-dimensional vector, well, let's think about it. Length is going to be, if we're writing down the component form, the vector is in standard position, so its tail is at the origin, and its head is at u1, u2. And the length of the vector is just going to be the distance formula from the head to the tail, but the tail is the origin, 0, 0. So the distance formula in this case just becomes square root of u1 squared plus u2 squared, and we write this length u like that. Now, that looks like the absolute value, and for a good reason actually, but it just depends on context again. So here, when we write down length of a vector, it's the radical of u1 squared plus u2 squared. On a similar note, the length of a vector v in 3 space is just the square root of the sum of the squares of each of its components. So if I want to find the length of the vector negative 1, 4, well, its length is going to be the square root of 1 squared plus 4 squared, which is the square root of 17. The length of the 0 vector is always just 0. So that's how you can compute the length of vectors. And now let's talk about scalars, scalar multiples. So remember, a scalar is just a constant. It's just a number. So for any number c and any vector v, what does c times v mean? Well, I'm going to give you the formula. I went ahead and wrote it down because it's exactly what you think it should be. CV is multiply each component by c. So CV1, CV2, that's when v is a two-dimensional vector, or when v is a three-dimensional vector, then it's CV1, CV2, CV3. Okay, so what are some of the properties of scalar multiplication? Well, if the number that you're multiplying by is bigger than 0, then the vector CV points in the same direction as the vector v, but its length changes, and that's where the term scalar comes from. C quite literally scales the length of v. So here's v, and if you multiply it by 2, you get a vector twice as long, or 3, you get a vector 3 times as long, or maybe you want to multiply by a half and you get a vector half as long. So when c is positive, it's just quite literally scaling v. It's the same vector, and it just gets longer and longer depending on c. Okay, what about when c is less than 0? Well, then you actually flip the vector. So if this is your v, then multiplying by negative c is going to flip you the other direction. So when c is negative, cv points in the opposite direction as v, and the length changes as well. So you can scale it in exactly the same way, but flipped. Important detail, what's the length of the vector cv? It's the absolute value of c. So this is absolute value times the length of v. So it's the absolute value of c times the length of v. Exactly what you think it should be. All right, so we say that two vectors, a and b, are parallel if one of the vectors is a scalar multiple of the other, i.e. you can write maybe b is equal to some scalar. I should have a vector hat on b. B is a scalar multiple of a for some scalar c. So I wanted to draw just a couple of pictures with you. So maybe let's switch to red. So here is my vector a. Here's a. And then what would 2a look like? Well, it would be twice as long. So there's 2a, and here it would be roughly, these are all guesses by hand, there would be a over 2. And here would be, if I wanted to do minus 2a, then I would have a vector pointing this way. I would flip it, flip the direction of a, and then multiply it by 2. So this would be minus 2 times a. So hopefully you get the picture. All right, so moving on, a unit vector. A unit vector is just a vector whose length is exactly 1. So given a non-zero vector v, it's important that we think about non-zero vectors for this. So v is not the 0 vector. then it turns out that you can simply divide v by its length. So v over length of v. By the way, this is legitimate because when I'm saying divide a vector, I'm really saying multiply by 1 over the length of v. I'll show you in a minute. So this vector is the unit vector pointing in the direction of v. So let's just figure this out with an example. So I want to find a unit vector pointing in the direction of this vector w. So let's just start by sketching w. So w, you're going to go from the origin out to 1 on the x-axis. I'm going to go every other dot here, if you can see the dots. So 1, 2, 3, 4. So we're going to be sitting up here. So 1 and then 2. So here is a sketch of the vector w. I want to find a unit vector pointing in the same direction. So the first thing that I do is I compute the length of w, which is square root of 1 plus 4, which is square root of 5. My unit vector is going to be 1 over the length of w times w. And so I just get 1 over square root of 5, 2 over square root of 5. Not the nicest numbers in the world, but the point is that's a vector, and that is a unit vector. And if you were to plot it, you would find that it looks exactly like this. And its length is 1, length 1, and it's pointing in exactly the same direction as u. So let's end this video here, and in the next video, we'll talk about how you can add and subtract vectors.